you serious? Are you serious? Okay, guys. Now
Streaking through space, light is the fastest thing in the universe.
It could circle the Earth 7 times in 1 second.
As it reaches us across vast distances, it reveals the history of the cosmos.
We're able to look back in time.
Light travels at 186,000 miles per second. Its speed is an ultimate barrier. Nothing can go faster.
We have never, ever broken the speed limit.
But is the answer final? Will spaceships ever speed faster than light? Is it even worth trying?
To give up without trying is just giving up.
It can neither be touched nor felt. It is an abstract quantity of immense impact, the rate of motion at the very heart of all existence, the fundamental linchpin of the universe that we call light speed. Planet Earth, where speed is in demand, the fastest people, vehicles, and technologies seem to crawl in a cosmos where light speed is king. More than king, the speed of light is the cornerstone on which the universe is built.
There's a famous saying in physics, which is that the speed of light is not just a good idea, it's the law.
The speed of light is one of the most important speed limits in the entire universe.
The speed of light, 186,000 miles per second, is just incredible. I mean, if light traveled in a circle around the Earth, it could circle the Earth 7 times in 1 second. That's an incredible speed.
That incredible speed is the first thing we encounter when confronting the phenomenon of light. To say it is fast is a colossal understatement.
It's amazing to me that when I talk on my cell phone, I can talk to somebody clear across the country, and I'm not really aware of any time lag. And that signal is going from my phone to a tower, up to a satellite, back down, and it seems instantaneous. So we really take for granted the speed of light could practically be infinite to us.
Physics professor Clifford Johnson of USC is an avid bike rider. Circling a track, he considers trying to cover the same 186,000 miles that light does in 1 second. He'll find, however, that his work will be cut out for it.
To travel the distance that light moves in just 1 second, it would take me 22 months on a bike moving at 12 miles an hour, cycling 24 hours a day.
But the speed of light, in relation to the speed of life, makes our world work in just the way we've come to expect.
One of the beneficial effects for humanity of having the speed of light be as fast as it is that what you see is what you get.
Light speed makes everyday experience virtually instantaneous. When the light bulb goes on, you see it right away. Anything that happens around you registers immediately. And certain experiences make it crystal clear that light travels faster than anything else, including sound.
One interesting consequence of the great speed with which light travels is that you see a flash of lightning essentially instantaneously, but you hear the thunder only later on.
But light speed has its limits when stacked up to a place as large as the universe.
We think that the speed of light is unimaginably fast on a human scale. However, in astronomical terms, it's actually kind of pokey.
And so it's ironic that when the Apollo spacecraft blasted into space, traveling at what seemed an amazing 25,000 miles per hour, the speed of light proved frustratingly slow when it came time to talk to astronauts 236,000 miles away on the lunar surface.
So when the astronauts were on the moon and people asked Neil Armstrong, "Hey, Neil, what's it like up there?" Several seconds went by between the question and Neil Armstrong's answer.
Neil, this is Houston radio, check over. Hi, Roger. Houston, loud and clear. Roger, loud and clear, Houston. Roger, bud.
And those several seconds were not because he was thinking about the answer, but rather because it took 1.3 seconds for the signal traveling at the speed of light to reach Neil from mission control, and another 1.3 seconds for his reply using radio waves to come back. And that's 2.6 seconds without even thinking.
Okay.
The 1.3 seconds it takes light to travel from the Earth to the Moon is pocket change compared to other celestial bodies. Light from the Sun, for instance, takes more than 8 minutes to get to the Earth.
And if the sun were to disappear right now, if the sun were to suddenly vanish, it would take 8 minutes before we would even feel the shock wave and see the effects of a disappearing sun.
The limits of light speed also make communicating with Earth's far-flung spacecraft a special challenge. It takes up to 44 minutes for signals to travel back and forth to the probes exploring Mars. More than 3 hours to Cassini at Saturn. And over 29 hours to Voyager 1, the most distant of all, now heading out of the solar system. Still, these distances are trivial on a cosmic scale. We can almost understand the 10 billion miles separating Earth from Voyager. But what's next? The nearest star is a red dwarf named Proxima Centauri, nearly 25 trillion miles away. That's 25 followed by 12 zeros.
I am often asked a question, how can you as an astronomer really comprehend these vast distances, these huge numbers? And the answer is, I can't. The human brain really doesn't wrap itself around numbers that big. Occasionally, I actually write out how many zeros there are in kilometers from here to a galaxy, just to see how huge that number is. But in reality, of course, as astronomers, we would be spending all day writing zeros unless we came up with a better unit to use. And that's what a light year is. A light year is approximately 6 trillion miles. It's the distance that light travels in 1 year.
Using light years to describe distances opens up another dimension of light speed's character. Think of it. Sirius, the brightest star in the sky, is 8.6 light years away. That means we see it not as it is today, but as it was 8.6 years ago. We see the bright star Vega as it was 25 years ago, and the red supergiant Betelgeuse as it was 500 years ago.
It's a wonderful gift of nature that because it takes time to travel, we're able to look back in time. The further out we look in distance, the further back in time we look. We would have no idea what our cosmic history was if the speed of light traveled instantaneously.
Laura Danley is curator of the historic Griffith Observatory in Los Angeles. With light's ability to take us into the past, she's assembled a stack of photos that tell light speed's story of the universe in snapshots, looking back in time to its beginning, more than 13 billion years ago, to the present day.
I'm putting together a scrapbook of the history of our family of galaxies, and that shows all the galaxies that we can see with our telescopes as far back as we can see with our telescopes.
Each photo in this album, then, shows something in the universe with a look-back time equivalent to its distance in light years. The famous Crab Nebula, 6,500 years ago.
I'll see you guys at 12 noon Eastern today on the coming apocalypse. Give your life to Jesus Christ, because these are the prophetic signs that the Bible said would come. Earthquakes in divers places. Are you serious? Are you serious? Okay, guys. Now
Streaking through space, light is the fastest thing in the universe.
It could circle the Earth 7 times in 1 second.
As it reaches us across vast distances, it reveals the history of the cosmos.
We're able to look back in time.
Light travels at 186,000 miles per second. Its speed is an ultimate barrier. Nothing can go faster.
We have never, ever broken the speed limit.
But is the answer final? Will spaceships ever speed faster than light? Is it even worth trying?
To give up without trying is just giving up.
It can neither be touched nor felt. It is an abstract quantity of immense impact, the rate of motion at the very heart of all existence, the fundamental linchpin